delta b, that is x, that is equal to b minus a by n. So let me consider the equation f of x equal to x cube e to the power of minus 2x minus 2y. That is between the interval, what is that lowest interval? 0, and this is 0.2. And the improved Euler's method uses the method of h is equal to 0.05. Hello and warm welcome to one and all. It is Dr. Ravikumar YB, Department of Computer Science, Vidhyaashram, First Grade College, MYSURU, the Temple of Excellence. In today's session, you will learn about the Rungekutta second order method, Rungekutta fourth order method, as well as the trapezoidal method for few of the examples. If that is the case, the formula for Rungekutta second order method is this. That is y1 is equal to y0 plus k2, where k2 is equal to h into f of x0 plus h by 2 comma y0 plus k1 by 2, where k1 is equal to h into f of x0 comma y0. With this, I am going to calculate the second order method. What is the formula for Rungekutta fourth order method? So we have y of x plus h is equal to y of x plus 1 by 6 into k1 plus 2 times k2 plus 2 times k3 plus k4, where k1 is equal to h into f of x comma y, where k2 is equal to h into f of x plus h by 2 comma y plus k1 by 2. Similarly, k3 is equal to h into f of x plus h by 2 comma y plus k2 by 2. Similarly, k4 is equal to h into f of x plus h comma y plus k3. That is the formula we have used here. After finding this k1, k2, k3, k4, we will substitute into this equation to get the value of y using the Rungekutta fourth order method. If that is the case, this is the formula for fourth order method. What is the formula for trapezoidal rule then? This is the formula. We have an integration where the lower bound is b and upper bound is a. So we will do that delta b, that is x, that is equal to b minus a by n. That gives me the range of values between which the integration of f of x dx is to be done, where f of x is equal to this, that means delta x by 2, that means this delta x by 2 into f of x0 plus 2 times f of x1 plus 2 times f of x3, f of x2 plus 2 times f of x3 plus 2 times f of x minus 1 till then plus 2 plus f of xn. We have here, please note that we have f of x0 and f of xn are not multiplied by 2. Other than these two, everything else is multiplied by 2. So that gives the value of f of x into dx. So this is the formula to find out the method of solving the problem using the trapezoidal rule. Let me take up the example like this. The example, that is y f of x is equal to, that means y dash is equal to x cube minus x cube into e to the power of minus 2x. If I bring this towards this, minus 2y, this is the y dash, also called as f of x. F of x equal to x cube e to the power of minus 2x minus 2y, where y0 is equal to 1 and x0 is equal to 0. We have these terms. Find out the value of x equal to 0.1 and x equal to 0.2. That means when the value of initially we have x0 comma y0, where x0 comma y0 is equal to 0 comma 1. What is the value of x when x equal to 0.1? What is the value of y0? That is 0.1. What is the value of this? What is the value of this when the value of x equal to 0.2? What is the value of y? That means 0.2 comma this. This is to be determined from this value. If that is the case, what is the step size? H is equal to 0.1. This is to be considered. If that is the case, we have the terms like this. The same thing is rearranged into this form, which is of the equation. If I simplify this equation, what is the value I'll get? Let me take you into the details of it by the method of trapezoidal rule method. What does the trapezoidal rule method says? The trapezoidal rule method says that integration b to a to b f of x dx is equal to, what is the value of that? Delta x by 2 into f of x0 plus 2 times f of x1 plus 2 times f of x2 plus 2 times f of x3 plus so on up to 2 times f of xn minus 1 plus f of xn. That gives me the value of this method. If that is the case, what is the value of y0 then? We have x0 here, x1 here, x2 here. We have to find out x0, x1, x2. If this is n, we have to find out only this term, that is f of x0 plus 2 times f of x1 plus f of x2. This is to be determined, that is delta x by 2. This gives me the solution of f of x into dx by the method of trapezoidal rule. Because we have to find out only 0, 0.1, 0.2. If I consider this as x0, x1, x2, we will get the values as y1, y2 and y3. So we will substitute that into this equation to get the values of that using the trapezoidal rule. So let me consider the equation f of x equal to x cube e to the power of minus 2x minus 2y. If I say that x equal to 0, this becomes, entire thing becomes 0. Y is equal to what? 1. That is minus 2 into 1 is what? Minus 2. That means we have the value which is equal to that. Where f of x0 is what? F of x0, that means when it is 0, we have the term which is equal to minus 2 plus, what is f of x1? When the value of x1 is what? That has to be determined. What is the value of x2? That has to be determined. So finally, we will determine that. So if that is the case, we have to find out what is f of x1. F of x1 is equal to, that is this. What is the value of this? When the value of x equal to 0.1, that is 0.1 whole cube, that means 2 minus 2 times y plus 0.1 whole cube into e to the power of minus 2 into 0.1. This gives me the value of this y0, that is y1. We have the value like this. So if I do this operation, what is the value of this 0.1? That means 0.1 whole cube is equal to 1 by 1000. That is equal to 0.001 into e raised to the power of minus 2 into 0.1. E raised to the power of minus 2 into is equal to, that is equal to 0.8187307531. That has to be multiplied by 0.001 to give the value of y1 is equal to 0.0008187307531. This is the value of y1. So we have to find out the value. We have found the value of y1. I will substitute it here and multiply it by 2. So to get the value of this into 2, that is equal to minus 2 plus 1.637461,506 into 10 to the power of minus 3 plus, what is this f of x2? x2 is determined based upon this value. What is the value of x? X equal to 0.2. If that is the case, 0.2 whole cube, the x2. Let me calculate the value of x2. That is 0.008 into e raised to the power of minus 2 into 0.2. Shift e raised to the power of minus 2 into 0.2. That is equal to 0.6703200046. Now we have this term now that has to be simplified further, that is into 0.008, that is equal to this, divided by 2, to get the value which is equal to 0.017251074, that is this, plus 0.0016374610506 minus 2, which is equal to minus 1.9876374118. The entire thing must be multiplied by delta x by 2. What is delta x here? That is between the interval. What is that lowest interval? 0, and this is 0.2. 0.2 minus 0 is what? 0.2. That is 0.2 divided by 2. That is equal to minus 0.19876374118. This is the final solution. That is by the method of trapezoidal rule. Using the Rungekutta method, we have the value of k1 is equal to 0, 1 here, where x0 equal to 0, x1, y1 equal to 1, we will get minus 2. That means minus 2 is substituted here to get the value of k2. Then after simplification, we will get the value of this. That is for k2. Similarly, k2 is used here to get the value of k3. That means the k3 value is equal to this k3 value. K4 is equal to this. We are using the value of k3 here, that is at this time. Then if I further simplify this, I'll get the value which is equal to this. So k1, k2, k3, k4 are determined. Then finally it is substituted into this equation to get the value of y1. If that is the case, what is the value of y1? That is 0.1. That is y of 0.1 is equal to, if I simplify these terms, that is what is y0? That is equal to 1 plus h by 2, that is 0.1 by 6 into k1. What is the value of k1? That is minus 2 plus 2 times k2. What is the value of k2? That is this term, minus 1.799886895 plus 2 times k3. K3 is what? That is minus 1.819898206 plus k4. What is the value of k4? That is equal to this, minus 1.635201628. That is this value. If I simplify this term, what is the value I am getting? 2 into minus 1.799886895, that is equal to minus 2 plus of minus 3.59977379 plus this term. If I simplify this term, what is the value I am getting? 2 into minus 1.8198982006, which is equal to minus 3.6397964112. This is the value. If I further simplify this, I'll get plus into minus, that is minus 1.635201628. That is this value. If I simplify and everything is multiplied and divided by 6, we'll get this term, that is equal to this. If let me simplify the whole term now, minus 2 minus 3.59977379 minus 3.6397964112 minus 1.63520168, which is equal to minus 10.874777183. That is 0.1 divided by 6 into this plus 1. If I further simplify this, that has to be multiplied by 0.1 to get this term, that is divided by 6. to get the value of this plus 1. That is equal to y of 0.1 is equal to 0.8187538028. This is the value of y of 0.1. Let us cross verify that in the next slide. Look at it. We have found the value which is equal to 0.8187 53803. That is the value of y of 0.1. If that is the case, how can I find out the value of y of 0.2? That is y of 0.2. How can I determine that? By finding the value of k1, where k1, x1 is what? 0.1 now, y1 is what? That is this value. So 0.1 and this value. If I simplify this, I'll get this term. Then k2, I will use this term into this k1. So to get the value of k2 like this. Now k3 is using the value of k2. So let me use this term here. That is this plus this gives me the value which is equal to this. That is the value of k3. k4 is using the value of k3. So by solving this, I'll get this term. So y2 is equal to y1 plus h by 6 into k1 plus 2 times k2 plus 2 times k3 plus k4 gives me the value of this. So if I simplify this term, I'll get the value which is equal to 0.7670592417. This is by the method of Rungekutta, fourth order method. That means y of 0.2 equal to 0.67059247. That is the value of y of 0.2. This is by the method of Rungekutta, fourth order method. If I use the second order method, what is the value I am getting here? What is the formula? That is k1 is equal to h into f of x0, y0, where k2 is equal to h into f of x plus h by 2, y plus k1 by 2. That is this, where y1 is equal to y0 plus k2. That is, this is the formula I am using here for finding the solution using the Rungekutta second order method. Instead of finding the k3 and k4, if I solve and find out the value of k1 and k2 and substitute it into here, I'll get the value of y1. No need to find out k3 and k4. If I substitute the value of k1 and k2 here, what happens? We have k1 and k2 here. What is the value of k1 here? Minus 2. That is minus 2. That is k1 is equal to minus 2. What is the value of k2? k2 is equal to, what is that? k2 is equal to this term, minus 1.79988 minus 1.79988 6895. 6895. If that is the case, what is the value of y1? y1 is equal to, what is the value of y0? It is 1 plus of k2. What is this term? Plus of k2 plus of minus means we will get minus. That is minus 1.799886895. For solving this equation, what is the value of y1? Y minus this means 1 minus this means 0.79988. No. If I solve this term, what is the value I'll get? Let me show you that. 1 minus 1.799886895. What is the value of that? Yes. It is y1 is equal to minus 0.799886895. This is the value of y1. That is y of 0.1 is equal to this value. Similarly, if I substitute this value into this k2, that is k1, k2, what is the value of k1 and what is the value of k2? Then y2 is equal to y1 plus k2. If I do this operation, I'll get the value of y2. So we have k1. What is the value of k1 in this case? That is k1 is equal to this term, minus 1.6366 minus 1.6366 88875. Then what is the value of k2? k2 is equal to minus 1.471 338457. then y2 is equal to y1 plus k2. If that is the case, what is the value of y1? Y1 is obtained here, that is this term 0.79988 minus 0.79988 6895 plus k2. What is the value of k2? This term. Plus of minus, this becomes minus, that is minus 1.4713388457. That is the value of this. If I simplify this term, I'll get the value of y2. That is y of 0.2 is equal to, let me simplify this term, minus 0.799886895 minus 1.4713388457, which is equal to minus 2.271225352. That is the solution of this. That is this plus, this leads to the value which is equal to y of 0.2 is equal to 0.671451562. That is this. This is the value of y of 0.2. What is the value of y of 0.2 using the Rungekutta fourth order method? That is 0.67059. What is this method? 0.67014515562. That is by the method of Rungekutta second order method. About fourth order method, this is by using the fourth order method. This is by trapezoidal method. This is by trapezoidal method. So with this, I am concluding this session, and also we have certain examples like this, the same examples given here, and we have one more example here, that is y is equal to e to the power of minus 2x by 4 into x power 4 plus 4. You can solve it by using the method of trapezoidal and Rungekutta second order, Rungekutta fourth order method, with h is equal to 0.1 as the step size for this, and the improved Euler's method uses the method of h is equal to 0.05. We have different methods for the same question. So if you look at this, you will see that the h is equal to 0.1 considered here, h is equal to 0.05 is the value, then exact solution after 1, that means 0.0 to 1.0, 10th iterations, we are getting the value which is equal to 0.169169,104, and by the method of improved Euler's method 0.169680,673. See the difference between this with this. So with this, I am concluding the session. Thank you very much. Thank you one and all.